Hello, I'm a presenter of Team6 conducting research on Absolute World Tower. Before starting our presentation, let me remind you of our last week presentation briefly. Last week, we discussed why the Med Studio had used the Skydeck for the slab formwork. And also, we talked about the main components and the applications of Skydeck. Starting this week, we will look at the most prominent features of Absolute World Tower, the consequential structure problems and solutions. At each successive level, the floor plate rotates in a range of 1 to 8 degrees. Absolute tower can be designed in a simple way. Copy ellipses and rotate them. Fill the slab surfaces and close facade. In this way, we can design overall structure and express appearance of building. It starts to twist from below and increases its rotation initially by 1 degree to a maximum of 8 degrees. Rotation per floor for a total cumulative floor plate rotation of 209 degrees. The building's vertical middle section represents the maximum 8 degrees rotation. Building has two typical lines is different from each floor. The window line determines the territory between internal livable space and balcony of cantilever structure. The slab line determines the overall appearance of the building. Every floor is different and always unique. Basically, it is building in a floor-by-floor project. Because of the symbolic rotating slab, three structural challenges were given to the structural engineer of this building. First, the traditional concentric loading of columns was not appropriate for the unique design of the building. Secondly, traditional flight tables were not appropriate for this construction because they would have resulted in large unsupported panels when the rotation of the floor plate was more than 2 degrees. Third, the rotating floor plate caused additional vertical thermal transfer issue. Among these three problems, today we are going to talk about the first problem. What technique can be used to solve the load support of this building, whose center of gravity varies from floor to floor? In order to discuss the technique of bearing the load of the absolute wall tower, we should understand its flat plate structure first. It is a type of architectural structure consisting of columns and slabs without beams, which are horizontal structural members connected to columns of vertical materials and supporting load. The load generated by the slab is transferred directly to the floor through the column, so that it falls to the ground. Which wall should be used in flat plate structures where the load must be supported only by columns and slabs without beams? The unique design properties of the building also required an innovative structural design method. The solution is load-bearing wall structure. Different from column structure, load-bearing walls support each slab with sustaining accurate consistency. The load given by upper floor is distributed to each walls located each section of the floor. As such, regardless of the rotating slab, the load-bearing wall is located at the same position on each floor. However, the length of wall is adjusted to fit the slab of each layer in such a way that the length of the wall is extended or contracted to fit the rotating slab size. There is another method to sustain structural stability from collapse generated by unique design. It is self-consolidating concrete. General building has a beam to support the slab load. But if the structure is designed without beams, the slab should have high volume and thickness. And also, it needs finer concrete specification called for 70 megapascal columns, walls, and beams, and 50 megapascal slabs. Self-consolidating concrete can also make this intensity. This is self-consolidating concrete's final advantage. Self-consolidating concrete spread consistently all over the space, so the slab can sustain accurate consistency. Next week, we will investigate other construction methods and devices associated with slabs and walls. There are references of this presentation. Thank you for watching the video.